Okay. Everybody, we'll give you just a minute to tune in here. My name's William Friedman, and hi, girl with ribbons, how are you? Great to hear from you. All right, so people are starting to line up here. Great. This is William Friedman from the Cross Country Local. Welcome from, what's the name of this bar?
Clark.
The bar in Ebensburg, Pennsylvania, across from the courthouse. And
I've forgotten already.
Clark Johnson was from The Wire. Anyway, something like that. Anyway, I'm here getting reacquainted from a friend of mine from high school in Allen High School, Allentown, Pennsylvania, class of '81. Ouch.
Indeed.
And he is now a professor of mathematics at Indiana University of Pennsylvania, about 45 minutes north of here in Ebensburg. Say hi, Gary.
Hi, everyone.
Now, Gary is going to use his math professor mad skills to show us how to figure out square and cube roots with our hands, with just our hands and our heads, and no calculators needed. So I'm going to, okay.
Cubes will be difficult to draw, but we'll see.
Okay, so I'm going to turn this towards...
Well, the idea behind a square root, so for example, there is a square of size 9, and the square root we all know is 3, because that length is 3.
Right.
So the square root is associated with the side of a square having that area. So suppose we wanted the square root of, let's do an easy one, 65.
Okay. So you zoom in here. 65.
So that would mean the area of this square here is 65.
Right.
Well, we all know there's a square of size 64 in here.
Right.
So let's label it that. And that means this L-shaped thing, for you word fans, the gnomon, the L shape, would have area 1.
Okay.
So that L shape is actually made up of 2 rectangles and a little square.
Okay.
So what you can do to start out with this is ignore the square.
Okay.
So if the square root of 65, we can call that a plus b. That would be the length of that side.
Okay.
So if you look at the picture, it's actually 65 is a squared, which is that square in there, plus 2 of these rectangles.
All right.
So that would be side B, and that would be side A. So 2AB plus B squared.
Well, that looks like...
And you might know that from this in algebra class, right?
Right, that is...
A squared plus 2AB plus B squared. Who says you never use algebra in real life, right?
Okay,
I'm not sure this is called real life.
Oh, no, in real life, I wouldn't have missed The Walking Dead last night. So, no spoilers. Periscope, do not tell me anything about The Walking Dead last night. I'm sorry, go ahead, Gary.
Well, this bee will consider dead, and it will walk away.
Okay.
Because it's so tiny. So what we do is, well, 65 is approximately 64 plus 2AB except A, right? That will be 8 by 8, right?
Okay.
So A is really, so that would approximately be 64 plus 16B.
Okay.
And then you could solve for B. So 1 is approximately 16B, so B is approximately 1 over 16. So the square root of 65 is approximately A plus B, so 8 plus 1 over 16.
Okay, great. Now, is there a practical application for that?
Well, if you want to know square roots and for some reason your phone has, and all your calculators have blown up. So no.
Okay.
Well, actually, no. There are algorithms that, I mean, you could write algorithms to do much more complicated things than this, but it's the idea of approximation.
Right.
So no application for this particular thing, but there are many algorithms that are generated in a manner like this. And of course, you could do this more and more. You could start over now and say,
Okay, hold on. Let me. You're getting lots of hearts, by the way. Every time someone sends a. Gang, you just send a few hearts Gary's way, just real quick.
There we go. Give myself a heart.
Oh, he's giving you a heart, Periscope.
So you could do this again and say, well, you know what? Now my new approximation is 8 and 1/16. And then you just do it over again. Right? You could iterate this. So you would say, well, 8 and 1/16 plus b squared is 65. And then you start the whole process over again. And then you find a new value of b, and then you just keep doing it. You can iterate as much as you like.
Okay, great. Professor Gary Stoudt, Indiana University of Pennsylvania.
More than you ever wanted to know about square root algorithms. If you care, this goes back to the Babylonians.
All right. Well, what happened to them? They're so smart.
Well, the Babylonians sent their knowledge towards Greece and the Arabic world and towards China, and they appropriated it and went about their business. Well, of course, the Babylonians now, it's in Iraq. The Tigris and Euphrates.
Yeah, let that be a lesson to you math nerds.
As John Stewart would say, right? Mesopotamia.
All right. Well, there will be plenty of other interesting lessons along the road here. William Friedman with Dr. Gary Stoudt.
None more interesting than this lesson, I'm sure.
I'm sure. I have complete confidence. We're never gonna top that. Just real quick, does he or does he not look like Harold Ramis?
Of course.
Yeah. All right.
Yeah, I've never heard that before in my whole life.
So thanks for tuning in to the Cross Country Local. Please follow us on Periscope. Please invite others to follow us on Periscope. Follow us on Facebook at Cross Country Local, at GoFundMe on the Cross Country Local campaign, and on Twitter and Instagram at #XCLocal, X-Ray Charlie Local for Cross Country Local. Thanks for tuning in, and you should really save this on your hard disk, because this is going to come in important. You're going to need this later. And I'll see you along the route.